Solve. A rubber ice hockey puck has a 3.3 inch diameter. What is the area of its circular surface? Use 3.14 for pi. Round to the nearest tenth if necessary. Well, they're talking about a hockey puck, and I would definitely think that because of diameter, even if I don't know what a hockey puck is, diameter implies that it's a circular object. So I'm going to try to draw in perspective what a hockey puck looks like roughly. And it's made of rubber. So they're telling us that the diameter of the circle, like if we flip this, if we take a view this way, view it this way, then we turn it on its side and look at a circle. Here's the view that we're looking at. So we're able to now distinguish that it really is a circle. How does a circle described? It's described by two different ways. First of all, they tell us that the diameter of the circle equals 3.3 inches. A diameter runs 3.3 inches. A diameter runs from one edge of the circle through its center and then all the way straight over to the other edge. So we're looking at a circle with a diameter of 3.3, but when they ask us for area, the area of a circle formula, the area of a circle formula is pi equal to pi r squared. It's calculated using this number pi, which they tell us to use 3.14 for pi, but it's also based on the circle's radius, not its diameter. So we're going to need, they give us pi, we're going to use 3.14 approximation for pi, but we need to derive what the radius of this circle is. Now, in other words, because the formula requires it of us. A diameter. What's inside of a diameter? Well, from the center of a circle to one of its edges is one radius. But from the center of the circle through to the other edge is another radius. So what we're looking at here is there are two radiuses, two radii, inside of, equal to, one diameter. One diameter contains two radii. If we need radius of a circle, which we do for this problem to calculate area, then we solve this equation. We solve it for r. I need to know what one radius is, so we take two radii and divide by 2. Whatever this coefficient of the variable is, I'm going to divide by whatever it is. Then that would give us what one radius equals in terms of diameter. And to find that, what we do to one side to make one radius happen, we do to the other side of the equation to keep the equation in balance. So what we find out here is 1 times d is d divided by 2. So here's the formula for radius in terms of diameter. Radius equals diameter divided by 2. So what we can do to calculate the radius that we need is to substitute the actual diameter that they give us for this hockey puck, for the circular hockey puck, and we substitute that value, the diameter, in for d. So here's what d equals, 3.3 inches. 3.3 inches. So what is the radius? Well, we're going to do long division to find that out. Won't take much time. We're going to take the numerator, 3.3, and we're going to divide by the denominator. Divide the diameter by 2, and that'll tell us what the radius equals. Maybe we can even put it down here. The radius equals, okay, 2, well, the 2 is a whole number already. When we're dividing decimals, we want the divisor to be a whole number. We move, at that point, we move the decimal point up into the quotient area for our answer that's going to appear here. And then we begin dividing, like 2 into 33. 2 divides into 3 once. 1 times 2 is 2. Subtract. We get a 1. Bring down the 3. 2 divides into 13. 6 times 2 is 12. 7 times 2 is 14. So it must be 6. We need to drop back down to a number that is less than 13. 3 minus 2 is 1. We might put in a 0 and bring it on down, because I noticed that if we did that, 2 divides into 10 5 times, and that's a nice way to end this long division, is on a remainder of 0. So the radius of this hockey puck is 1.65. Look, the units of inches definitely belong next to this number for radius, because it's a measurement of something in real life. And it's a unit of measurement that was provided to us, so it stays as part of this problem. Okay, now we're ready to put all our substitutions in to the area formula. So here we come up to the area formula. The area equals, well, if we're using this approximation for pi as 3.14, because pi is an irregular, it's an irrational number that goes on forever. We haven't found the end of pi. It's irrational. There's no repeating digits. As soon as we approximate it, as it is shown here, to the nearest hundredth, then anything that we derive from an approximation, if there's an approximation involved in a calculation, anything we derive from that approximation, like area, is an approximate. I'm saying that area is approximately equal to 3.14 times, here's this r is going to go in there, the square of r goes on the outside, and then here comes our calculation of radius. We're going to put everything to radius right there, 1.65 inches. The unit goes in here. It's going to get squared as well. Now what takes over here, approximately equal to, we're going to continue with the wavy equal signs, area equals, what takes over now is the order of operations. The order of operations, as we know, is an agreement around the world, so we all, mathematicians and scientists, arrive at the same answer to the same problem all around the world. There's multiply here in this expression, but there's also an exponent here, and we generally work these from top to bottom, which means we need to do exponent first. We need to evaluate this exponent. So what we do here is keep the 3.14 where it is and work on squaring. We're going to do this exponential expression first. We're going to evaluate that and see what it becomes. Now if I have 1.65 squared, that translates to 1.65 times 1.65. We're going to work this out vertically. 1.65 times 1.65. It's a little bit of work without a calculator, so I'm going to just go ahead and demonstrate what those steps are, and we'll use colors to make it easier to detect. The first digit times the first digit. 5 times 5 is 25, carry a 2. 5 times 6 is 30, plus 2 is 32, carry a 3. 5 times 1 is 5, plus 3 is 8. Now when we go to the second digit, I might use cyan for that. When we go to the second digit and back to the first, before we actually start, we would insert a 0, then begin. 6 times 5 is 30, carry a 3. 6 times 6 is 36, plus 3 is 39, carry a 3. 6 times this 1 is 6, plus 3 is 9. Then we could end here our partial products, perhaps in red. Before I multiply this digit times back to the first digit of the other number, we're going to insert 2 zeros for proper place value positioning. 1 times 5 is 5, 1 times 6 is 6, and 1 times 1 is 1. Now we're ready to add up our numbers, our partial products, and get a total product. 5 plus zeros is 5. 2 plus zeros is 2. 8 plus 9 is 17. 17 plus 5 is 22. Carry a 2. 2 plus 9 is 11. 11 plus 6 is 17. Carry a 1. 1 plus 1 is 2. Now we're obligated to adjust, make accommodations for that these actually were not two whole numbers. If it was 165 times 165, I would be done. But it's 1.65 times 1.65, so we're going to look at this as we have 2 decimal places to the right of the decimal point in this number. We have an additional 2 decimal places to the right of the decimal point in the second number. We take these 2 digits, digit counts, and add them together, and then we're going to take this decimal point and move it 4 times to the left. 1, 2, 3, 4 times to the left. So 165 squared is 2.7225. We just did the square of the radius. Now, of course, the exponent is done, and we move on to the multiply step of the order of operations. And we have a long division to do, a long multiplication, excuse me, to put these 2 numbers together. I'm going to move over to a clean space in our scrap paper, and I'm going to say 2.7225. I put the longer digit decimal number above the shorter one. Here comes pi at 3.14, and we're going to multiply. It's a raised times dot. So I'm going to change colors so we can track our digits again. 4 times 5 is 20, carry a 2. 4 times 2 is 8, plus 2 is 10, carry a 1. 4 times 2 is 8, plus 1 is 9. 4 times 7 is 28, carry a 2. And 4 times 2 is 8, plus 2 is 10. And we carefully, line up as we go. We line up our digits, our place values, which changing colors actually helps. So look, before I go from 1 back to 5, I'm going to insert 1 0. 1 times 5 is 5. 1 times 2 is 2. 1 times 2 is 2. 1 times 7 is 7. 1 times 2 is 2. It's just 1 times that top number is itself, really. Now I'm going to change to red. For this digit back to the first digit, this time we insert 2 zeros to hold our proper place values. 3 times 5 is 15, carry a 1. 3 times 2 is 6, plus 1 is 7. 3 times this 2 is 6. 3 times this 7 is 21, carry a 2. And 3 times this 2 is 6, plus 2 is 8. Now it's time to add these numbers together. Zeros, all these zeros, let me change colors one more time to black perhaps. Zeros add up to 0. 0 and a 5 is 5. 2 plus 9 is 11, plus 5 is 16. 16 carry a 1. 1 plus 8 is 9. 9 plus 2 is 11. 11 plus 7 is 18. Carry a 1. 1 plus 0 is 1. 1 plus 7 is 8. 8 plus 6 is 14. Carry a 1. 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 1 is 5. And 8. Now we go through and count the number of decimal places that we're working with. Let's go ahead and do that in red. If I count the number of places, I see 1, 2, 3, 4 places to the right of the decimal point in this number. And in the pi number, we only see 2 decimal places to the right in pi. I'm going to go ahead and add these 2 numbers together to make 6. And it tells us to move this point as if these were 2 whole numbers. That's this answer, but they're not 2 whole numbers. We're going to move this to the left 1, 2, 3, 4, 5, 6 times. And that's where the decimal point winds up. Now the last thing they ask us to do in this problem, because here's the product of these 2 numbers. The last thing they ask us to do, well, let's go ahead and write it down. Our answer at this point is approximately equal to 8.548650. And the units, by the way, this inches, I forgot to write in here that inches get squared right here. Both of those products, the 165, we squared it, but here come the inches squared. They belong here next to this number. Now, the last part that they asked us that I was beginning to mention is when we're being asked to round to the nearest tenth, this is the ones place, this is the tenths place. We look one digit to the right of the place value that they wished us to round to and ask, is that 4 greater than or equal to 5? And we actually say, of course, 4 is not equal to 5 and 4 is not greater than 5, so we answer no. In that case, we round down, and when we round down, we do not change this 5 at all. In decimals, when we round decimals, after we decide whether to round down or round up, which we're rounding down, we're keeping this 5 as it is, we delete all of these digits to the right of the decimal. So in the final answer, we have the area of the circular hockey puck is approximately 8.5 inches squared. 8.5 inches squared. Now, because they're asking, here's a small technical problem. Because they're asking for the area of the circular surface, I kind of take that as there's one area here is approximately 8.5 square inches. But if I was to really kind of think this through, isn't there a second area down here that's another 8.5 square inches? Because the problem's worded a little bit strangely. Well, not so much. I mean, if I was to account for the total area of the hockey puck, I really would add 8.5 and 8.5 and get 17 square inches. However, when I look at the answer choices, I realize they're really just asking me for the one surface. So I'm not going to worry about this, but this is an issue with word problems. Sometimes they're not worded so well. So we have to, use our best judgment and select the best answer of what's available. I do conclude that they're only talking about one of the circular surfaces based on that the answer set does not contain a choice of 17. So we make our final selection. The correct answer response for this problem is 8.5 square inches. Answer C if this was a test or a final exam.